Hello, welcome back student. Today we are going to see the next example of PDA. Okay. As you know, the formal definition of PDA is Q sigma tau transition initial state, top of the stack is initially and the final state. These are the 7 tuples are there in PDA, as already we discussed in the previous classes. Okay. So here the main important thing, as you know, the Q is nothing but is a finite number of state, and what is sigma? Sigma is finite number of symbols. Okay. And tau is stack. Okay. And delta is a transition, and the transition is this, sorry. Okay. For transition, this is a condition. What is this transition? Delta is equals to Q cross sigma union epsilon, and what is this? Cross tau. Okay. And here we will get Q cross tau star. Okay. So this is a delta, and how to do this to get the output, and what is this? This is a, we can say this is a transition function. Okay. Transition function. And what is Q0? Q0 is a initial state, Z0 is from the stack, and F is a final state. Okay. So in the exam you will going to get the question like this. It will give the language L is equals to W, means whatever the string you have, W is nothing but like this string, whatever string you are taking, that is W, and belongs to 0, 1 closure, 0, 1 closure. What does it mean? What does it mean? This is telling equal numbers of zeros and ones. Zeros and ones. That means let's check it out. What is the zeros and what is ones? So here if I write 0, 1, the answer, if we write the answer 0, 1, is it valid? Yes, equal number of zeros and ones. Okay. If I write 0, 1, 0, is it valid? Yes, it is valid, equal number of zeros. But here it is not mentioned. Why it is valid means it is not mentioned here, like if it is 0, n, 1, n, if it is like this, then this condition will be false, because in this condition every time first the 0 should be come. So this is a valid. If we go with 1, 0, okay, this is not valid if we go to this condition. But here it is giving 0, 1 whole closure. Whole closure means just it is telling equal number of ones and zeros in any order. In any order. One, you can get the first 0 or you can get second 0. Okay, like this. Let me check another one. 0, 0, 1, 1. Is it valid? Yes, this is also valid. 1, 1, 0, 0. It is valid? Yes. Is it valid? Yes, it is valid. Why? Because equal number of ones and 0 in the given string. Okay. So I hope you understand this. Whenever we have this kind of language, based on that you need to design a string in such a way that this condition, this language should be satisfied. Okay. If I take this, any one of this, then it is a valid. Okay. If Let me check here 1 0 1 1 0 0. Is it valid? Yes, this is also valid. 1 1 1, 3 ones are there, 0 0 0, 3 zeros are there. So equal number of zeros and equal number of ones. Let's check it out this. Okay, fine. So now we will take this example and we will solve how we will design the NFA. Okay, we will design the NFA, finite automata. Okay, the first one is, it is telling Q0 is an initial state. First thing, Q0 is a initial state. So just take it out, Q0. Okay, Q0 is a initial state. Fine. Now, so we are considering this string. Okay, we are considering this string. So here 1 0 1 1 0 0. So let's check it out. This is satisfy the given language or not. Okay. Now, first, in the first Q0, we need to check where is the header, the first string. In the last example, I shown you whenever we have a 0, we have to add in the stack, and that will be valid for this one. Okay, but here whenever you have 0 or 1, any one means in 0 and 1, if you get any one of the symbol first, just add in the stack. Like here we are getting 1, so add the 1 in the stack and remove when we occurred the 0, Okay, the same operation in the last example I shown you. I have taken the first is 0, now I am taking a 1. You can add 1 or 0 in the stack, but the corresponding should be equal. Like if I am adding 1 here, so whenever I am occurring 0, we need to remove 1. Okay, if sometime you will not have this one starting from here example, so you have to add the 0 in the stack, and whenever the 1 is occurred, you need to remove. So this is a same thing. Okay, now I am adding 1 and the same corresponding of zeros, I am popping the data from the stack. Okay, popping the symbol from the stack, top of the stack. Okay, so the first one is Q0. Okay, and here what is the first I have now here is 1. So it is 1. And what is at the top of the stack now? Now is Z0. Okay, so my header at the first point, and in the stack we have the Z0. So what is this rule of PDA? It will remove this, like I shown you the step 1, step 2, same thing I will show you today also. I will erase this. Okay, and this is step 1. Okay, now I am going to step 2. What is step 2? In the step 2, we will have first here we need to remove this Z0. After 1 comma Z0, we need to remove 0 and you need to add again Z0, and whatever the symbol is available in the string, that you need to add 1. Okay, this is step 2. And what is the header? Header is now 1. Okay, so simply we need to write here 1 comma Z0 is 1 Z0, whatever the thing is available in the stack, first 2 means at the top of the 1 and the next top of the stack we need to add as it is. Okay, 1 comma Z0 and that what will be the answer? 1 Z 0. Okay. This is step 2, and it's moved from 1 to next. Now it's moved the header from 1 to 0. Okay. Now whenever we have a 0, okay, let's draw here. Whenever we have a 0 comma, what is the header now here? Is 0, and what is at the top of the stack? Is 1. Okay. So whenever we have like this, at the top of the stack you need to remove, in the step 3 you need to add again. Okay. Let us see. Here we need to add 1, 2. So here 0 and 1. What is the top of the stack? Is 1. So what I told you, whenever the 1 is added in the stack, and if 0 is there, the corresponding 0, we need to remove 1. So what is the answer here? Just we need available, we have only Z0, and Z0 is a top of the stack. And what we are doing here, we are not performing any operation, just we are taking pop-up. So that means it is epsilon. It is epsilon. Okay. Okay. So what is our next header point? Our next header point is 1. Next is 1. Okay. Now whenever we have 1, okay, here we have the 1, and what is at the top of the stack here? This is 3. This is 3, step 3. Okay. And what is at the top of the stack? Z0. So whenever we have 1 comma Z0, what we need to do? The same thing, 1 Z0. Okay. 1 Z0. This is a answer. That means what will be the step 4? Step 4 is just we are adding 1 and Z0. Okay. So what is in the step? That Z0 is there, and we are adding 1 also. We are adding 1 also. Okay. Now step 4 is finished. So what is the thing? Just 1 Z0. This is also finished. What is the next header? Our next is 1. Again 1. So whenever we have 1, okay, so we need to add in the push in the stack. So here I am just taking, sorry, okay, and what is the next header? Our next header point is 1 comma, and what is in the stack, the top of the stack is 1. So when we have 1 comma 1, so simply in the 5th step, as I told you in the previous example also, in step 5 we need to do 1, 2, 3. So here Z0, here what is the thing available? Z0, 1, and simply just we are popping this 1 and adding again. So 1, 1. Where is the header now? At the top. So just whatever we are adding here, 1, 1, simply. How we did for this 1 Z0, in the same way we are adding 1, 1. Okay, this is a rule of PDA. You need to remember this. Okay, now it is 1. Now next one is, our next header point is going to 0. Okay, so whenever we have 0, okay, that time if the top of the stack is 1, what is the performance? what it will perform? 0 is the top of 0 is in the string and 1 is the top of the stack, and we will get the epsilon. Okay, that means we need to remove this 1, we need to remove this 1. So in the step 6, we need to remove top 1, okay, and here we have the top of the stack. Okay, here step 6, 1 z0, we remove this because we need to pop the data whenever we have 0 like this. Okay, now the next is next pointer, next header is moved to the 0. Okay, in the 0. So when we have 0, okay, same thing, 0 comma 1, 0 and the top of the stack is 1. Okay, so what we have now? 0 is a string and 1 is the top of the stack. So 0 comma 1 top of the stack, and we got the epsilon. Okay, we got the epsilon. So what is remaining in the step 7? Step 7, in the step 7 we have the data only z0, only we have z0. Okay, and this is a top of the stack here. Okay, and what is remaining in the stack string? We don't have anything. So what is this? Epsilon. Okay, if nothing is there, if the string is finished, then we need to use the epsilon. Because of that, we will say epsilon NFA. Okay, epsilon NFA. So here 0. Now if we have the epsilon, okay, so you can take like final state. Whenever we have a like this, so you can say the final state. So I am taking here, okay, and I am telling something is final state. Like consider here Q1, okay, Q1 is a final state. Q1 is a final state. When it is going, when epsilon comma, what is at the top of the stack? Z0, okay, then only it is going to the final step. Epsilon comma Z0, then we are getting the epsilon, and it is moving from one state to another state. If you don't want to move, no problem, but here we need to say any one of the final state. Q0 is the initial state and Q1 is a final state. Okay, so this is about the final answer. Okay, epsilon Z0 is epsilon, then we will get the final output. So once again I will repeat this, then it will be easy for you for understanding. So this is a formal definition of PDA, okay, and this is a delta, how it is performing Q. Okay, what is Q? Is 1 cross sigma. What is sigma? Is Z0. Okay, sorry. What is Q? Q is Q0. Okay, Q is Q0. And what is sigma? Sigma is in the string is 1. And what is cross tau? What is tau? What is available in the stack? Z0. What is available in the stack? Z0. Okay, so 1 comma Z0 the answer. Okay, here Q cross tau closure. Okay, let's take another one. Q0, 0, Q0 is Q, and 0 is sigma, and what is 1? This one is tau. What is available in the stack? That is tau. And what the answer we are getting? Epsilon. Why we are getting epsilon? Because we have to take out, if you are adding 0, so here I am adding 1 here in the stack. So whenever the 0 occurred, at that time we need to correspond it, then and we need to pop the data from there. Then we are not performing any operation. Because of that we are writing epsilon. Okay. Next header is moved to the 1. What is this 1? 1 is sigma. Okay. 1 is sigma. And what is this one? This one is we are adding in the stack. We are adding in the stack here. Okay, step 4. So 1 comma 1, then 1 1. We are getting 1 1. Okay. So this is 1. Another is, if it is go to the 1, sorry, okay, how we got the 4th step? We got from this. We got from 1 comma z0. In the step 3 we have z0. So from 1 z0 at the top of the stack, then we will add the 1. Okay. Again we have a 1. Then again step 4 is also performing the same operation. 1 comma sorry. In the fifth step we are performing this 1, and what is at the top of the stack is 1. Then we are popping 1. What is the header in the stack? We are taking out. Again we are adding 1 1. We are adding this 1 and we are adding again this 1. Okay. So this is about in the step 5th. And what is the step 6th? Step 6 is 0. So when we have a 0, okay, when we have a 0, 0 comma, what is at the top of the stack? Top of the stack is 1. So 1 comma 0 is epsilon. We are not performing any operation, just we are popping the data, but we are not adding or something else. So here next, what is the next? After removing this, after popping this, only we have 1. What is the header? 1. So what is remaining string? Remaining string is last one is 0. 0 comma top of the string is top of the stack is 1 slash sigma, sorry, epsilon. Then this also remove. What the thing we are doing, in place of 1, whenever 0 is occurring, we are removing this 2. When 1 1 is there, corresponding this and this is removing. This and this is removing. Then only we can say this language is satisfying the given string. Okay, and no input should be present in the string, and no input symbol should be present in stack also. Okay, at the last we should have z0. At the last must we have the z0. Okay, and what is in the step 7? In the step 7, after finishing all the string, we have the epsilon. So in the epsilon comma, what is in the stack? Top of the stack is z0. Then the answer we are getting is epsilon. That means we are getting the Q1 is a new state, and that is a final state. I am telling that is a final state. Okay. So this is the, okay. So here we design the finite automata. So now we need to write in this function, delta function. Okay. So how we can write the delta function? That is delta, okay, What is the first one? Q. What is Q? Q0, okay, comma 1. What is 1? String sigma. And what is Z0? That is tau. And what the answer we are getting for this? We are getting the answer Q cross 1 Z0, 1 Z0. What is this? This is Q. What is this? This is sigma. What is this? This is tau. What is this? This is Q. And what is this? This is delta tau closure, tau closure. Okay, let's see here. So here you can see Q cross sigma, sigma, and this is tau. What is the answer for this? Q cross delta, Q cross tau star, Q cross tau star. Okay, so we have written the first function for this. While saying here, the next one is delta. Next one is delta. What is Q0, comma, Q0, comma, this 0, comma 1. What is the answer we are getting for this? Q0 is going to Q0 only, and we are getting epsilon. We are getting epsilon. Okay. The next one is delta. Next we are taking 1. So where it is going? From Q0, comma 1, comma 1. Okay, sigma tau. And here what is Q? Where it is going? Is going to Q only, Q0, Q0, and what the answer we are getting? 1, 1. Okay, fine. Now the next one is delta. Okay, delta, where it is coming from Q0, comma epsilon, epsilon, comma Z0, Z0. Okay. So what the answer we are getting is going to the next state, where it is going from Q0 to Q1. So here we need to write Q1, and what is the answer we are getting? Epsilon, epsilon. Okay. So this is Q1, comma epsilon. Okay, like this. So what the answer we finish? 4. Okay, 1, 2, 3, 4. So delta Q0, 1, Q0, comma 1, comma Z0 is Q0, 1, Z0. This is a function, transition function. Okay, this is a transition function. I hope you understand this. Okay, this is very simple. In the exam you will get the question like this. You need to identify which string will be satisfied for this language. You need to find and you need to solve this. Okay, and here if you no need to get confused if it is giving here n0, n1, n2 is, if it is writing n0 is w, whatever the string is there, that should be same as n1 of w, the string. So this string should be satisfied. So this language, most of the important part is this one. I hope you understand this. Let's we will stop here. We will see the next topic in the next class. Thank you.